The routing algorithms can be broadly categorized in a perspective that is, what is the discovery process through which the nodes or the vertices in a network discover each other, measure the costs associated along each segment, and determine the shortest paths to each other. Link state is one of the well-known routing algorithms that is based on the shortest path finding mechanisms such as Dijkstra's algorithm. In this module, we shall convince ourselves about link state being a global algorithm at the network level, and then we'd look at its complexity. The reference that I've chosen is by Kuros and Ross. Link state is a global routing algorithm. When I say global, it actually means that all the routers, the nodes or the vertices, as we may call them, have complete topology picture before them and the cost associated with every link. Each node, or in other words, each router, constructs a map of the connectivity in the form of a graph. So you can imagine that each router has a copy of the overall map. And it shows which nodes are connected to which other nodes. So the global routing algorithm, such as link state, keeps a local version of the global picture of the whole network. The implementation through link state is carried out as follows. Each node independently calculates best path from its own self to every possible destination in the network. That is, if there are n nodes, and if you are sitting at one of the nodes, so the total number of discoveries would be n minus 1. The collection of best paths, which is determined through comparison of multiple paths leading between a source and destination, the routing tables are built. This is an iterative process. It means that when k iterations are performed, paths to k destinations can be discovered. The complexity of link state is actually the complexity of a full mesh, because the nodes in the network are associated with each other through links that could form loops, either becoming a partial or a full mesh. So the complexity is highly dependent upon the messages which flow on these links, represented as n into n plus 1 divided by 2. Mathematically, in terms of omega notation, the message complexity and the time complexity is of the form n square.